Let us find the radius of the small inscribed circle. Locate the center Q of the small inscribed circle and label its radius, r. Join line D, O and G, Q. Let angle C, A, T equals beta. Hence, consider triangle C, A, T. Use Pythagoras theorem. The square of line A, C equals the sum of the square of T, C and the square of T, A. Substitute values and we have that the square of 10 equals the sum of the square of y and the square of the sum of y and 6. Expand bracket, combine like terms and simplify. We obtained, finally, that 2 times the square of y plus 12 times y minus 64 equals 0. Use general quadratic equation formula to solve for y. Y equals negative 12 plus or minus the square root of 12 squared minus the product of 2, 4 and 64 all divided by 4. Simplify and we have that y equals negative 3 plus or minus the square root of 41. We will not accept the negative result. It is because for length measuration, negative value is invalid. It implies that y equals the sum of negative 3 and the square root of 41 in units. From triangle C, A, T. Line A, T equals the sum of 3 and the square root of 41. And by trigonometric identity, AT divided by A, C equals cosine beta. Substitute values and we have that the sum of 3 and the square root of 41 all divided by 10 equals to cosine beta. Thus, beta equals 19.89 degrees as shown on the screen. Recall that cosine alpha equals 7 divided by 9. This was derived or obtained earlier. It implies that alpha equals cosine inverse of 7 divided by 9, which equals to 38.94 degrees. Consider inscribed small circle and join AO. Line D, A equals line G, A. It is because tangent lines to a circle from the same external point are equal. Thus, QG divided by G, A equals tan half of the sum of alpha and beta. Substitute values and we have that are divided by 6 equals the tan half the sum of 38.94 degrees and 19.89 degrees. It implies that R equals the product of 6 and tan half the sum of 38.94 degrees and 19.89 degrees, which equals to 3.38289607686. Therefore, the required value of r equals 3.38 units to 2 decimal places.